We're talking about inscribed angles today. Inscribed angles. And so, first of all, the measure of an inscribed angle is 1/2 of the measure of the entire arc. So we'll write that down and then I'll tell you what I mean by that. So it's 1/2 the measure of the arc. It's called the intercepted arc. Talk about it in just a sec. And also, it's 1/2 the measure of the central angle. So let's look at what I mean by that. Right here it asks you for the measure of angle PRU. That's this guy right here, PRU. And it gives you, although you don't see it up here, it gives you that this is 118 degrees over here. And then it also gives you that this is 27 degrees. So you've got those two things, and it asks you for PRU. So this angle right here is going to be 1/2 of its intercepted arc. Well, what's the measure of its intercepted arc? 118. So it's 118 divided by 2. That's the measure of PRU. So 118 divided by 2 is 59. For the measure of arc, SPU, we're looking at this arc right here. It wants the measure of that arc, SPU. We know that PU is 18, but we don't know what SP is up here. You got it. 20, whoop, that's not going to work. 27 times 2 equals 54 degrees. So now we just say 118 plus 54, that's 2, 6, 7, 172. So that's the entire measure of arc SPU. Guys, is arc SPU a minor or major arc? Major, because it has three, it's designated by 3 letters, major arc. Okay, so that was 172. And finally, SRU. Well, it wants the measure of SRU, this entire big thing, and we know that we have this measure right here, SPU. What was this measure? 172. So what is SRU? This whole thing is 172, so SRU is 172 divided by 2. That's right. Oh, you gotta catch me when I do this. They're not looking for the measure of the angle, are they? They're looking for the measure of the arc. So, thanks. Thank you. Yeah, we're going to do 360 because that's the entire circle minus what we already know, 172, and that's going to give us the other side of the circle, which is this. Thank you. Come on, Mr. Kelly, get your head in the game. 188 degrees. Okay. Next thing says, if an inscribed angles of a circle intercept the same arc, then, alright, well let's take a look at these inscribed angles. We've got one inscribed angle that's A, C, B, and another inscribed angle that is A, D, B, but they are intercepting the same arc. This guy right here. Well, if these two angles are intercepting the same arc, what do we think we know about their measurements?
Same.
They're the same. Exactly. Exactly. Because whatever AB is, this is going to be 1/2 of AB, and that angle is also going to be 1/2 of AB. And guess what? So is this angle. 1/2 of AB. It doesn't really matter where the vertex is. As long as the vertex is actually on the circle, then that angle is going to be 1/2 of whatever arc it intercepts. So we'll say the angles are congruent, and therefore we can say the measure of angle ACB is, well, actually we're talking about measure, so we're going to say equal to the measure of angle ADB is equal to the measure of angle AEB. Notice, guys, that all of these angles share the same endpoints, A and B. It's just the vertex that's different. Okidoki. Find the measure of EDF. So they want us to find this guy right here, EDF. And they give you, what is that, 2x plus 3? Alright. And then we've got 75 minus 2x. Excellent. Awesome. We do what? What do you think? They've got the same intercepted arc right here. Perfect. Alexis gets 100 for the day. 2x plus 3 equals 75 minus 2x. Why? Because we know that those two angles are equal because they have the same intercepted arc, right? You got it. I'm going to bring baby to mama. And I get 4x plus 3. I'm going to subtract 3 from both sides. And I get 4x equals 72. Or x equals 14. Oh! Sorry. I'm going too fast. 18. Thank you. Now that's x equals 18, right? So that's not the actual answer. We've got to do... Yeah. I want to plug them in, and I'm going to plug them into both just so I can check and make sure both those angles are equal. I've got 36 plus 3 equals 39. And then so this angle should also equal 39. Let's see. 75 minus 36. And 75 minus 36 does equal 39. So I'm good to go. So make sure you're checking your stuff when you're doing your quiz and your test. Just plug that x value in if it's something you set equal to each other. It's a nice, easy way to check. Okay, DBA is a mess. Example number 3, find the measure of angle DBA. Well, first of all, I'm going to try to sort DBA out from everything. So, starting with D, going down to B, and then up to A. And I've got to find the measure of that angle. So I'm going to say, that's my x right there. I know that the measure of this small angle, DCE over here, is 33, right? And the measure of ECA is also 33. So, what's the measure of this guy right here if the measure of these two angles adds up to 66? 132. Remember, your large arc is just twice your inscribed angle. And so if my large arc is 132, what is my x? 66, sure. Okay. All right, an inscribed angle subtends a semicircle if and only if. All right, well, so what do they really mean by this? Let's take a look. We've got this inscribed angle, and the angle's endpoints are at the same endpoints as the diameter right here. So we know a few things about this. First of all, we know that if this is the diameter, then what is the length of this arc right here, or the measure? 180 degrees, right? Because it's just half the circle. Remember, the diameter cuts a circle in half. Well, if my intercepted arc is 180 degrees, what's the measure of my inscribed angle? 90, right? Because, remember, my inscribed angle is just half of my intercepted arc. And so, what if I had my angle right here? What would the measure of that be? Still be 90. Because it's still 1/2 of the intercepted arc. What if I had my angle right there? Still 90. It doesn't matter where that vertex is. If you have an inscribed angle whose endpoints are on the diameter like that, that angle is going to be, guess what, 90 degrees. Okay? So that's what that means. If you have the arc is a semicircle, oops. And that means it equals 180 degrees. Then the inscribed angle is going to equal 90. All right. So example number 4 wants you to find the value of A, and it's basically asking just what we were doing right here. It says that this is 5A and 20 degrees. You know, what's the name of segment WI? It is a hypotenuse, but as far as a circle goes, oh, I kind of gave this away, didn't I? Diameter. That's a diameter, right? And so we have the endpoints, our inscribed angle. Its vertex is right there, and the endpoints are on the diameter. And so, what is the measure of this angle right here? 90. Good. And so, how would you set up this equation? Good. 5A plus 20 equals 90. And then you would just subtract 20. And you'd have 5a equals 70. Or now a equals 14. And of course I'm not done. I want to make sure that that this is right. So I'll say 5 times 14 plus 20. I want to make sure that equals 90. 5 times 14 is 70. Plus 20 does equal 90. So I'm good to go. Check. All right. Here's your theorem. If a quadrilateral is inscribed in a circle, then... All right, so a few things about this. If you have this quadrilateral and it's inscribed in a circle, then you've got... let's say that angle, ABC, and this angle, ADC. Well, I know that ABC, my red angle, is going to be 1/2 of my red arc. Does that make sense to everybody? Okay? So this is going to be 1/2 of, let's just say 1/2 of red. Alright? I know that ADC, my blue angle, is going to be 1/2 of my blue arc. Okay? 1/2 of blue. My circle is just made up of the blue arc and the red arc, right? So if I add these two guys together, I'm going to get, what are the degrees I'm going to get if I add both of these angles together? 180. Very good, because the red and the blue equal up to 360, and those two angles are half of that. So these two opposite angles and these two opposite angles, basically whenever you have a quadrilateral, the two opposite angles are going to equal 180. And what's that called when two angles equal 180? Starts with an S, ends with an supplementary. Yeah, supplementary, that's correct. So your opposite angles in a quadrilateral that are inscribed in a circle are going to be supplementary. Opposite angle supplementary. So for our conclusion here, we know that angle ADC, no, you can have a 0, and ABC are supplementary. And same thing goes for the other two opposite angles. Alright, so let's take a look. Which of the following quadrilaterals could be inscribed in a circle? Alright, so we're looking at the opposite angles to check if they are supplementary, right? So I'm going to look at my opposite angles here. What is 85 plus 95? 180. And what is 110 plus 70? 180. So can this be inscribed in a circle? Check. And just for fun, I'm going to try to inscribe this in a circle. Ah, beautiful circle. Don't judge my circle. Don't. Alright, this one's a little bit more difficult. Takes a few steps here. So, what shape is this? Trapezoid. And we've got parallel lines here. This is parallel to that. And so, think back to your days of proofs. When you have two parallel lines cut by a transversal, does anybody remember what we know about those same side interior angles? What's that? The opposite angles, what? Oh, they're supplementary. Elijah, go, leave. All right. These guys, these angles are supplementary. Now, they're not congruent, right? They're just supplementary. Same thing with these angles right here. Boom, boom. Those angles are supplementary. Now, the other thing about this is that I've got these two tick marks, which means that this side is congruent to that side, which means this angle is congruent to that angle, and this angle is congruent to that angle. Alright, so I know all this stuff about these angles. I know that these two guys are supplementary, but I know that these two guys are congruent. Same thing here, these two guys are congruent. Well, if these two guys are congruent, let's say that their measures are 80. Let's just say. That's 80 and that's 80, right? And if these two guys are supplementary, what would the measure of this one be? 100, right? Because they both have to add up to 180. And then what's the measure of this one? They're congruent. 100. So I know that these guys are supplementary. What about these guys? Yep. What about these guys? Yes. So I can draw a circle perfectly around this. Inscribe a perfect circle. So go ahead and try that now. Try to inscribe that in a circle. It has to be perfect, or else it doesn't count. It's like I have a circus circle over here. Oh, that is a perfect circle. Shh. All right. Yes. 70 plus 70. 140. Wah, wah. That must equal 180, but it does not. So circle, no. No, we would have to do some kind of weird oval shape with this guy here. So that does not work. All right. Let's look at example 6. We've got 10b and 69. And then 6b and 20. 3b and 25. Oops. And nothing over here. All right, we've got to find the measure of each angle of GHJK. What do we do? Ethan, help. 6b plus 20 plus 3b plus 25, and do what? Equals 180. Excellent. Because I know that those two angles are supplementary, right?
Yeah.
And then once I find b, I can plug it into here. What happens when I find this angle? I can find the other angle. Cynthia, how do I find h? Subtract k from 180, and then I get h. Good. Take a look at your homework, guys. There's one question that I want to go over with that. This is homework. This is tonight's homework. And then we're going to do one thing on last night's homework. Okay, this one looks a little daunting here. But I can promise you it is not nearly as complicated as the video games that you play at home. Alright? So, this guy